HCF and GCF. HCF simply means highest common factor, and GCF simply means greatest common factor, and both are same. HCF or GCF is the factor that is common between two or more numbers. It is the highest number that can divide a set of numbers without a remainder. Let's go into the lesson and make more sense out of this. So the procedure for solving or finding the HCF or GCF of a set of numbers is as follows. 1. Express each of the number in its prime factors. Now this is to say that if you don't understand or know what a prime factor is, check out for the previous lesson on prime factors. You need to go through that lesson before coming to this one. 2. Identify the common factor or factors between each group or each set of numbers. 3. Multiply the factors if they are more than 1. Okay, so we'll make more sense out of this. So before we get into the lesson, let's talk a little bit about index notation. So for index notation, when you have a number such as 5 raised to power 2, this does not mean 5 times 2. No, this simply means 5 in two forms, which is 5 times 5. This is 1 and this is 2. That is simply what it implies. So this simply means when we say 5 raised to power 1 is equal to what? Just 5, means 1 or 5. Having said that, it simply means that, let's continue from this point. If we have 3 raised to power 4, we simply say 3 times 3 times 3 times 3, such that we'll have 1, 2, 3, 4. So if we have 2 raised to power 3, it simply means 2 multiplied by 2 multiplied by 2, and we'll have 1, 2, 3. 2 in 3 forms. Having understood the basics of index notation, this is not a full lesson on index notation, but because we are going to be employing this during the course of this lesson, we have to talk about it briefly. So let's go ahead and solve questions on GCF and HCF. So for the greatest common factor, which is GCF of 8 and 12. Now let's solve for the HCF of 8 and 12. For the first method, let's use factors. What are the factors of 8? 1 is a factor of 8, 2 is a factor of 8, 4 is a factor of 8, and 8 as well is a factor of 8. Now, if you don't understand how I'm able to generate the factors of 8, I don't want to keep this lesson long. You can check out for the lesson on how to find the factors of a number. Now, let's go for the factors of 12. 1 is a factor of 12, 2 is a factor of 12, 3 is a factor of 12, 4 is a factor of 12, 6 is a factor of 12, and 12 is a factor of 12. Amongst these two numbers, what are the common factors? 1 is common amongst them, 2 is common amongst them, and 4 is common amongst them. So when we say GCF or HCF, we're talking about the highest common factors. So amongst the common factor, what is the highest common factor? 4 is the highest common factor. Let's use another method and solve for the GCF or HCF of 8 and 12. Going back to the procedure, it says express each of the number in its prime factor. So check out for the previous lesson on how to solve for prime factors. Then we identify the common factors in each group and then multiply the common factors. So let's apply this now. So solving for 8, we have to divide. So 2 into 8, which means 8 divided by 2 gives us 4. 2 can still go, right? 2 divided by 4 gives us 2, and 2 can still go. So let's say 2 divided by 2 gives us just 1. And we are done with this. So let's express this as a prime factor. So 8 is equal to, taking the values here, multiplying them, 2 multiplied by 2 multiplied by 2. And we are done. So let's solve for 12. 12 divided by 2 is 6. Remember, we'll have to start from the least number, which is just above 1, and that's 2. But if 2 cannot divide, we'll go to the next value. This is why I need to follow the sequence by going through the previous lesson first before coming to this. Now, 2 can still divide, right? So let's use 2. 6 divided by 2 gives us 3. At this point, 2 cannot work again. So what do? We go to the next value, which is 3. 3 can divide. 3 divided by 3 gives us what? 1. So let's express this as a product of prime factor, we have 12 is equal to 2 multiplied by 2 multiplied by 3. So we'll have taking these values going here. So let's express this as index. So indexing this value gives us what? 2 raised to power 3. Remember before now I told you that when we have, it means another value 3 raised to power 5, it simply means what? 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3. So that we'll have 1, 2, 3, 4, 5. 3 in 5 forms. So here when we have 2 in 3 forms, it means what? 1, 2, 3. Hope that makes sense to you. Okay, so here we'll have 2 raised to power 2 multiplied by 3 raised to power 1. So as you can see, what is common amongst these two values? The common thing amongst them is what? 2 and 2, but their powers are not same. From this very point, what we'll simply do is that we are going to use the common factor, which is what? 2. Okay, let's say common factor is equal to what? The 2 index, right? But what we have to do, we have to work with the least indexed amongst them. So between 2 raised to power 3 and 2 raised to power 2, what's the least index? This is the least index, the smaller one. So the common factor here is just what? This least index, and that becomes our HCF. So therefore HCF slash GCF, any of it is equal to 2 raised to power 2. And what is 2 raised to power 2? It simply means what? 2 multiplied by 2, and that is 4. And if you check where 4 makes sense with our initial answer. So any of this method can work and it makes sense. So it simply means the highest common factor. So here we just simply solve for the factors of 8 and 12 and we're able to identify their highest common factor. While this other way, we used the index method and we're able to also identify exactly the same answer. Let's go ahead and solve more questions. It's becoming more interesting right now. Find the GCF of 16, 24, and 32. So using the index method, let's start from 16. So 16, start from the least number which can divide, which is 2. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. And we are done for this. So let's just write this as a product of its prime factor. We'll have 2 multiplied by 2 multiplied by 2 multiplied by 2. And we are done with that of 16. Let's go ahead and solve for 24. So 24, starting from 2 into 24 gives us what? 12. Okay, so 12 divided by 2 can as well go, which is 6. And 6 divided by 2 is 3. Then 3 divided by 3 is 1. So let's go for 24 right now. We'll have 2 multiplied by 2 multiplied by 2 multiplied by 3. And finally, we'll have 32. So let's divide 32. 2 divided by 32 is 16, right? Okay. Now 2 can still go. So 16 divided by 2 gives us 8. 2 can still go. 8 divided by 2 gives us 4. 2 can still go. 4 divided by 2 gives us 2. 2 can still go. And 2 divided by 2 is 1. And we are done. So for 32, we have 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. Now we are done expressing these values as a product of their prime factors. Let's index now. Indexing, this is 2 raised to power 4. Indexing here we'll have 2 raised to power 3 multiplied by 3 raised to power 1. Indexing here we'll have 2 raised to power 5. I believe at this very point, now you can see the common values here are 2, 2, and 2. So which means we cannot include 3. So what do? We have to work with the least common index. Continuing from this point, so the HCF or GCF is equal to the least common index. The common index here is 2, right? But what is the least amongst them? The least among them is 3. So what do we simply do? This becomes 2 multiplied by 2 multiplied by 2, and that's what 2 times 2 is 4, 4 times 2 is 8. So 8 is the GCF of 16, 24, and 32. So the index method is just quite simple. If you don't want to use the index method, then you use the traditional method. That means you have to write the factors of every of the numbers involved, then identify what's the highest common factor or value amongst the factors. We have another interesting question which says solve for the HCF of 15, 18, and 25. So first, let's express this as product of the prime factors. So 18, okay, 15, 2 cannot divide, so we'll start from 3. 3 into 15 is 5, so 3 cannot go anymore. We'll have to use 5, and 5 divided by 5 is 1. So 15 is equal to 3 multiplied by 5. Next is 18. 2 can divide 18, right? Yes. So 18 divided by 2 is 9. 2 cannot divide 9, we'll use 3. 9 divided by 3 is 3, and then 3 divided by 3 is 1. So for 18, we'll have 2 multiplied by 3 multiplied by 3. Then up next we'll have 25. What can divide 25? 2 cannot, 3 cannot, so we'll start from 5. 5 into 25 is 5, and 5 divided by 5 is 1. So for 25, we have 5 multiplied by 5, expressing this as product of the prime factors. So we can index to have 3 raised to the power 1 multiplied by 5 raised to the power 1. Then here 2 raised to the power 1 multiplied by 3 raised to the power 2. And here we'll have 5 raised to the power 2. As you can see, there is no common value between the index of 15, 18, and 25. Watch closely. We had 3 here, 3 here, and we didn't get any 3 here. And here we had 5, 5 here, while here we had 2. So since there is no common number connecting them, we already know that the factor of every number is 1 and not the prime factor. Remember that. So the factor of every number is 1, but 1 is not the prime factor of every number. So since there is no common index or value connecting these values, it simply means the HCF or GCF is 1. So therefore, HCF or GCF is equal to 1, simply because there is no common value connecting the whole of these values. Now let's use the traditional approach so I can see better. So factors of 15 will have 1, 3, and 5. 18 we have 1, 2, 3, 6, 9, and 18. While for 25, factors of 25 are 1, 5, and 25. We have 3 here, 3 here, don't have 3 here. We have 5 here, 5 here, but we don't have 5 here. So 6 is here, 9 is here, and we don't have any of that here. But if you're observant, you will see that we have 1, and it is common amongst all of them. Now this is to simply say, when you're using the index method like we've been doing here to solve for the HCF of a value or set of values, and you can't find any common number amongst them, just know that the HCF is 1. This might be a tricky question, but pay attention to it. Like, pay serious attention to this. Okay, find the HCF of 18, 42, and 24. So let's express this as product of their prime factors. Starting from here, 18 divided by 2 is 9. 2 cannot go anymore, so we use 3. 9 divided by 3 is 3, and 3 divided by 3 is 1. So 18 is equal to 2 multiplied by 3 multiplied by 3. For 42, can use 2. 42 divided by 2 is 21. 2 cannot go anymore, so we use 3. 3 here is 7. And then 7 divided by 7 is 1. So for 42, we have 2 multiplied by 3 multiplied by 7. Then 24. Starting from 2, we have 12. 2 divided by 2 is 6. And 2 divided by 6 is 6 divided by 2, yes, is 3. And 3 here is 1. So that we'll have 24 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3. Let's index 2 raised to the power 1 multiplied by 3 raised to the power 2. Indexing here 2 raised to the power 1 multiplied by 3 raised to the power 1 multiplied by 7 raised to the power 1. Indexing here we'll have 2 raised to the power 3 multiplied by 3 raised to the power 1. So at this very point, what is common amongst every of this number? 2, 2, 2. Wow, 2 is common. So let's bring that out. 2 is common. And what again is common? 3, 3, 3. 7 is not common. And 3. Now, after you've identified the numbers that are common, what's next? You take the least index. The least index for 2 here is 1. And the least index for 3 here is 1. So, having done this, we already done. HCF of 18, 42, and 24 is equal to what? 2 raised to the power 1 multiplied by 3 raised to the power 1. And that simply means 2 times 3, and that is what? 6. Viola, and we are done. And that's just simple. So, I haven't said that we've come to the end of this lesson. Please check out for the lessons on this series. Start from prime numbers, prime factors, how to find the factors of a number. Take it bit by bit before you come to this lesson. Now, one essential thing I want you to take notice is that while solving for the HCF or GCF of a number, is either you use the traditional approach of solving for their factors or you use the index method, which was taught in this lesson. Now, just one more thing, do well to like, subscribe, and comment to make sure this community is growing and we keep giving you amazing and beautiful concepts like this. Thank you.